Kid with big ears heard words too loudly. All right.
You know he's got like free Wi-Fi from that thing?
I know, right? All right, so how would you estimate a problem like this? How would you solve a problem like Maria?
First, I would
Alex, what would you do? Guys, I can't hear Alex.
I did 5 times 3.
All right. So we just started out right away saying that's 15. Okay.
put the decimals together and then put the single numbers.
What else would you do, Alex?
I did 58.6 times 10.
Okay, so he estimated this is 10. So he said, look, I don't know how to solve this problem yet, at least, but I do know how to solve this one. And he said that times 10 is what? 586. Cool.
Multiplied by 5.
Okay, and then multiplied by 5?
Yep.
All right, so he's saying that I should be able to do this and have it be the same as this. Multiplying by 10, then multiplying by 5. Now what'd you get? 2530?
2930.
2930. Okay, and then what'd you do?
I haven't gotten it quite yet.
Okay, cool. Well, let's estimate. 0.4 is about 0.5, right? So we get about half of this. What's half about 2,000? About 1,000. That's not good, because our answer should be a lot lower, right? And if we cut it by less than a half, it's going to be even bigger. So your assumption that we can multiply by 10 then multiply by 5 must be false. It's a good thought, though. He's on to something. Let's do this. I think this is what Alex meant. I think he meant take this and multiply it by 10, and then add it to this multiplied by 5. I think that's what he meant. Right? Times it by 10, then times it by 5, add them together, you get times by 15, right? This stands for 15 groups of this, right? So I've got 10 groups of this. I'm going to add 5 more groups of that for a total of 15 groups. That checks out. So Alex is right up to here. Now how are we going to handle this?
You do 586 times 5.
How would you do that?
I do paper pencil.
Can anybody think of a better way?
Calculator.
Any better ways?
Mental math.
What if we times it by 10 and then divide by 2? You see what I'm saying? Times this by 10, that's super easy. What's 58.6 times 10? 586. Now divided by 2. What's 586 divided by 2? Well,
247.
586 divided by 2. So what's 500 divided by 2? 250. What's 80 divided by 2? So we got 290, right? What's 6 divided by 2? 3. So 293. That's what that'll be. I times it by 10 and then divide it by 2. Same thing as timesing by 5, right? Times it by 10, I get 586, right? Divided by 2, I get 293. All right? So now our problem is this, right? How do we deal with this? What do you think? A couple ways to think of it. You could estimate 0.5, right? And then take away 0.1 of this. But you know what? If I'm going to figure out 0.1 of this anyway, check this out. What if I found 0.1 of this and then quadrupled it? What if I did 0.1 times 586 and then times it by 4? So what's 0.1 times 586? 0.1 times 586. When we times something by 10, we add a 0, right? We times something by 1, do we add any zeros? Times something by 1, do we add any zeros? No. So we add a 0 when we times by 10. We don't add any zeros when we times by 1. What are we going to do when we times by 0.1?
Go back.
Take a 0, yeah, right? Move it back. So 0.1 times 586 is 58.6. And now we're going to times it by 4, quadruple it. So I did 0.1 times 586, and we said that that equals 58.6. Now I'm going to take that number and times it by 4, and I'll get this answer, right? 58.6 times 4. Well, 50 times 4 is 200, right? What's 8 times 4? 32. So we have 232. What's 0.6 times 4? Same thing as 6 times 4 with a decimal in the middle, right? 2.4. So I'll write that out. We had 200 plus, times in this by 4. 8 times 4 you said was 32. And this is 2.4. So that's going to be 234.4. I'm going to add that with 293, right, from over here. Something's up. And how do I know it? Say it again. Does everybody hear what she's saying? Ms. Bechtel, would you like to explain what the issue is? All right, when we add these two together, we're not going to get this. So what's the issue? We got way too big. Does everybody agree with me up to here? That this is the same as timesing by 15. Times by 10, times by 5, add them up. We good with that? All right, so this checks out. Does everybody agree with me up to here? That 58.6 times 10 is 586. Good? Cool. Up to here, that 58.6 times 5 is the same thing as timesing by 10 and dividing by 2. We agree? You can check your calculator if you want. So our issue must have been somewhere around here, where I said this 0.1 times 586, and then times it by 4. You get us this. Do we agree that timesing by 0.1 and then multiplying by 4 will get us the same thing as multiplying by 0.4? Alex, what do you say?
Because you multiply by 1 instead of decimal.
What do you mean?
Instead of how you multiply by 0.1, you're not
Mm.
multiplying by the decimal, you multiply by 0.1, so it's going to be bigger.
So this 4 here, if I were to distribute it, I get 0.4, right? I distribute it here, I get a number much bigger. So I'm taking 0.4 of something much bigger than what I started with, right? So that's the issue. So my logic's a bit off. How would I do this, Alex? How would I do this step right here? Let me get another piece of paper. I like the idea of multiplying by 0.1, right, instead of 0.4.
It's kind of hard to think it's basically keeping the same is you multiply 0.1 by 4, but then multiply the other one by 0.4. Basically the same thing, huh?
If you do 0.4 times 586, you're still getting the 234.4.
Did we make a mistake? Did I write the wrong answer down earlier? 15, 15. Oh, yeah. 58.6 times 5 times 3 times 0.4. 0.4 times 58.6 times 5 times 3. I got 351.6. 0.4 times 58.6 times 5 times 3. I got 351.6. Right? We agreeing on that? Yeah?
But I think your faulty logic is between the second step and the third step.
So we must have an issue earlier on.
Yeah.
Let's start again. Do you agree with me up to here? That timesing by 10 and timesing by 5 and add them together gets to 15. Timesing by 15. 10 groups of this, 5 groups of that, add them up, we've got 15 groups of that. We good? All right. So that one's good.
I think that's what the problem was.
What about this? Five 8.6 times 10?
If you're multiplying by 15. Times 10 plus times 5.
We can check it on a calculator, right? We can pull it out. Is 0.4 times 586. And then we're going to add it to 58.6 times 5. So this was 234.4. Uh-oh.
That's the faulty logic right there.
We found an issue.
Yeah.
Was this true, though? Let's multiply them all together. 0.4 times 8.6 times 10. Right? And then we add 58.6 times 5. Let me get out the parentheses. Hate this calculator. Uh-oh.
Multiplying by 15, the same as multiplying by 10, then adding multiplying by 5.
You guys see the mistake? This does become this. That's totally fine. We'll figure out about the 0.4 being multiplied. Right now, it's multiplying all of them, right? Because they're all multiplication. But does the 0.4 ever touch this? It doesn't. So that was our major mistake. So I'm going to rewrite this. Does that check out? 0.4 goes to everything. If I distribute it, it hits this guy like it did before, and it hits this guy like it did before. We cool? All right. 586 times by 10 divided by 2. Well, I already know what this times 10 is, right? So I just add half of that. What's half of 586? Well, it's 250 plus 40, which is 290, plus 3. So 293. Cool. Now we've got a much easier problem to solve, don't we? Let's just add them up. What's 586 plus 293? Well, that's 9, right? This is how you guys would do it. 8 and 9, 7 carry the 1, right? 6 and 2, 8. And that's a fine way to do it if it gets the job done, right? You could also add 300 and then subtract 7. 886 minus 7 is 879. But, you know, teach their own. Now, how do we solve a problem like Maria? If you've been tuning out this whole time, here's the new problem. How do you solve a problem like that? Alex, I know you know how to solve it. Corinne.
Round the 0.4 to 0.5 and multiply by 879 by 0.5.
Okay.
Just divided by 2.
Say it again.
So like just divide.
Oh, I get what you're saying. Yeah, but then what do we have to subtract from this? Can you write it all out for me? So we do this, but we overestimated, right? So we got to take away how much? 0.1 of 879. So Corinne's right. We just divide this by 2. That's what 0.5 times something means, right? Half of something. So half of this. Well, if it was 880, it'd be 440, right? So 879, what's that going to be? 439 and a half. It's 440, right, if it was 880. But it's not. It's 1 less, so half less. And what's this going to be? This one's the one I want you to answer. What's this going to be? This one over here. Alex.
7.9.
Mm-hmm. Timesing by 0.1 is the same thing as dividing by 10. Moves it over. How would you solve a problem like Maria? This one right here. What would you do? Lots of ways to do it. Alex, go ahead.
Take 1 from 9.
Take 1 away from this.
Yeah, so the 5 can move to 15.
Say it again.
So the 5 moves to 15.
Regrouping.
Regrouping in what way? I'm not seeing it your way.
The decimal from the 9.
The decimal from here?
No, the other one.
Here.
First number.
Okay, what are we doing?
Making it 15 tenths. So you can subtract the 9 tenths from the 15 tenths.
Making it 15 tenths so we can subtract the 9 tenths from the 15. Ooh, okay. So we've got 439, or 438, let's do that. 438 plus 1.5. And what you're going to do is write this as this. I'm trying to think about how to write it, how the way you think it. And you're going to subtract these two from each other, huh? Okay. So what you're going to do is subtract 0.9 from this, and you get 0.6. So basically what he did, ignore this. All he did is subtract 0.9 from this first, right? Subtract 5 and then subtract 0.4 more. We get to here. Now what are you going to do, Alex?
Take 7 away from the 8.
Yep, take 7 away. So we're at 431.6 minus 80.
Take away 3 from the 23.
Take away how much?
30.
So 30. Is that what you want to take away? And now take away 50? Straight up? Not bad. It's an interesting way of looking at it. Well done. I think what I was thinking up here be to estimate this as 88. And then I can just take away 0.9 later, right? So I guess you did the 0.9 first, and I did the 88 first. That's the difference. You subtracted this first and then kept going, which is probably a better method than I'm about to use. So if I subtract 88, I'm going to subtract 80 from this. So I'm going to get 3, 6, 9. I like your way better. Subtract 9.9 first and get 538.6. Subtract away 8. Then subtract away 30. Whoops, 0.6. Then subtract away 50. Uh-oh. Or 1 off. Why?
0.9.
The 0.9? I took care of 0.9 here, right? Then I took care of 8 here. Then I took care of 30 here, and then 50 there. Is my 88? So I rounded this to 88, and it originally was what? Where's my, I can't even tell where I'm at now. It was originally 87.9.
I did a much simpler.
What did you do?
I took the 0.4, the 5, and the 3, and multiplied them all together. Because they were small numbers.
All right, hold on.
I put them all in parentheses.
So, what Ms. Bechtel did, she said, I'm going to do 5, 3, and 0.4 all times each other and get that taken care of first. All right, so 58.6 times 0.4 times 5 times 3. Right? And so you just did that first?
Yeah, and that came out to be 6.
All right, so 3 times 5 is 15, right? And we don't want to times it by 0.4. We could also do 0.4 times 5. What's 4 times 5? 4 times 5? 20. Move the decimal over once and you get 2. Times 3 is 6.
I got 6, and then from there, it's really easy to do. You can use your straight multiplication, or you can round it to 60 and then subtract the difference, that kind of thing. So that's
Right,
very
mhm.
easy to do from there, because you grouped all the little pieces together, and you just got a single number from there.
And that's the key. Grouping your little stuff together and then going after the big stuff later.
Yeah, you have all the little stuff, and then just to get the little tiny number 6.
I think it's how I would have done it.
Because they're all small numbers, you can do those in your head.
But I like that you guys found multiple ways and struggled with it. Nice job, Alex. Nice job, Corinne. Put it away.
Guys. Good job, everybody.
What? Yeah, I know. Buckets. All right, get out the thing we did yesterday.
Tomorrow, Mac.
Nope.
Not it.
Not tomorrow. We're gonna make it next week.
You're slacking, Mac.
I know. It's because I was sick. If I wasn't sick, we'd have it.
Mac,
Yo.
did you see me this morning?
Hmm?
Did you see me this morning?
No, I did not.
For like a quarter mile.
No, you did.
When I saw your car.
You're such a liar. This
And
guy
then
is such a
I
liar.
flashed you and I did the old famous Pepper's Way. No.
No way.
Are you
No
gonna
way.
roast us now?
You cannot be
No,
that
no.
focused on the road.
I am. I'm a safe driver.
These are bars for those times.
And that's right. 2 and 10.
It's actually 10 and 2.
Not if you're left-handed.
What question? Wait, isn't it?
93.
Yeah, because the airbags now.
True. That's true, yeah. I want him down here.
I ride at noon.
Yeah, is that how you...
Yeah.
Dude, this is 5 minutes.
I go like this and I lean over to my side and like this. Right, Tucker?
Let's take a look at... I believe we left off on 6. Right, we finished this whole page? Yep.
On what?
Let's take a look at 7. Did we do 7? I have my original copy. I don't know what happened to it. Yeah. Not sure what happened to my original copy. I had it in the 5th hour bin. Let's see if I can find it in here. If I can't, I believe we stopped at 6. We'll go to 7.
We're on 7, I believe.
I believe so too.
That's what I,
All right. Let's take a look at 7. So we got to compare these sides to see if they're proportional, right? So I like starting with the small triangle first. Let's look at our small triangle. What's the smallest side in our small triangle? I should have everybody on this one. Come on. Smallest side in the small triangle. What are we talking? 7, sir.
And 42.
15 goes with 42.
25 goes with 70. 30 goes with 80.
So we did small with small, medium with medium, and largest side on this triangle with the largest side on this triangle, which is 84.
I did that.
And the question is that a true statement? If it is, then we've got side, 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 right? 3 sides that are all in proportion. So let's check it out. How would you go about solving this, figuring out?
I just see it first. I put 42 divided by 52.
Well, what if you don't have a calculator? Because you won't on your quiz. 25 over 70, isn't that the easiest one to simplify? What are both divisible by? So that's really 5 over what? How many times does 5 go into 70? Better question, how many times does 5 go into 50?
12, no.
10 times. So 12 times to 60. 14 times to 70. Now the question is, will all these reduce to 5 over 14?
No.
How do you make a 15 into a 5?
Divided by 5.
Divide by 3. Is 42 divided by 3 14? I think it is. Divide both these by 5, we get 3 in the top. I'm sorry, divided by 3, we get 5 in the top. How many times does 3 go into 30?
10.
Alright, that's 12 left over. How many times does 3 go into 12? 10 and 4 makes 14. Alright, well how do you make that 30 into a 5? Okay, so we divide the top by 6, that gets us a 5, but can we divide the bottom by 6? Let's check it out. How many times does 6 go into 60? 10. So we got 10, right? Add 6 more, we're up to what? 66. Add another 6. 72. Add another 6. Add another 6. Try again. 84. So it's 10 plus 4, which is, well, Mr. Eads.
Yeah, see, I won't be able to do that on test. I'll probably forget it by end of class.
Don't use calculator. You got to think differently. Find the one that's easiest and try to get the other ones to match, right? So we get 5 over 14 for all of them, so all of them must be similar. So we've got by side, side, side similarity. These two triangles are similar. So we got TUV at the top. We want to match it up with the letters in the bottom. T here is made up of, let's label our sides. Maybe it'll make it easier. I think you guys liked this the other day. Large side, medium side, small side, right? It's like you're ordering at McDonald's. Small side, medium side, large side. So T is made up of the small and the medium side, yeah? So what's our small and medium side down here? Q. Triangle Q, that is. And then U, made up of medium and large. What's our medium and large down yonder? R. R. That's right. And then V is small and large. It's going to go with S down here, small and large, S. Okay. 8. Did they give us any sides? Nope. So it's going to be an angle, right? We've got scissors here and here. Eads is right. That's vertical angles theorem, right? That's right. But do we have 2 matching angles? I should clarify that these are green, not necessarily single bar, right? Nope, we only have 1 pair, so not enough. Or you can write unknown. Does that get you guys to laugh yesterday? My swiggles? Yeah. Told you I almost became a doctor. But I decided no, I want to help people and not take their money. So I became a public school teacher. There's nothing wrong with helping people and taking their money. It's just not my thing. Alrighty. Take a look at 9. We got 2 congruent angles here. That's good, right? Those are both the same angle. Eads, what do you see? That's right. These 2 are a scissor. Do we have 2 pairs of matching angles? Yep. A green pair and a blue pair. So by angle similarity, these are similar. So let's match up the letters. H in this triangle is going to go with itself. G, well, that's that blue angle. What's the blue angle in the other triangle? T. And F must go with S. How do you feel about matching up the letters? Is that okay? 10. All right. So if they are congruent or are similar, we're going to use side angle side, right? We've got 2 sides and an angle, right? Question is, do they work? Well, first of all, the angles do work, right? Those are the same. Now we got to compare the sides. What's the smallest side in the smallest triangle? 9. And what's the smallest side that we know about in the other triangle? So the question is 9 over 21 the same thing as 18 over 42? Now, there are a couple ways to solve this, right? You can keep reducing, not half. You can keep reducing, right? 9 over 21, both divide by 3, et cetera, right? Or, check it out. What would I have to multiply 9 by to make 18? If I multiply the bottom, do I get 42? Yeah. So they must be the same fraction. Right? Yep. One's twice as big as the other. Yeah. I see you, right? This triangle's just this triangle, but twice as big. The relationship's double. Now, if you want, you can simplify. Both are divisible by 3, so we get 3 over 7. Now, if they were to be the same, what would you have to divide 18 by to get 3? 6, right? So you should have to divide the bottom by 6. What's 42 divided by 6? 7, right? You could divide it by 3 and then divide it by 2. That'd work. You see what I'm saying? You see what I'm saying? Right? We just did it all in one go. I asked, since I know this is as simple as you can get, if they're the same, then that'll be a 3 and that'll be a 7. So how do I make that a 3? Divide by 6, right? Cool, that's fair. But I have to do it top and bottom. When I divide this by 6, do I also get 7? Yeah, I do. Checks out. Eads, you feeling better about that method? Okay. All right, so these triangles are similar. Let's match them up. That was by side angle side, right? We got two sides that are proportional and one angle in between. Let's match up our triangles. F must go with what? Everybody. U. Watch your mouth. G. I'm going to go with V. Why is it going to go with V? We have our longest sides, right? So we have large side here and small side there. Large side here, small side there. So V is made up of large and unknown, and so is G. So since G is large and unknown, V will be large and unknown. And then lastly, we have W with H. So F went with what? F? F? What's your profanity? Number 11. How many triangles do you see in number 11? Two triangles. We got a small one and a big one. Small one, and then the big thing, right? Is this a triangle? No. All right, so we need to compare some sides here. Little guy and big guy. Yeah, sits inside, right? So we know the lengths of the big guy, right? We know side FD and side FE, and we know side DE, right? We know all three sides of the big guy. If you want to, you can draw that triangle out and say that it's 88, 143, and 121. Now the little guy, let's draw him out. We know his bottom's 44, right? But do we know these sides? We don't, but there's a way to figure it out. How would you do 143? This side right here is going to be 143 minus 91, right? Does everybody see that idea? Whole thing's 143, that's 91, so what's left over is going to be this. So we need to do 143 minus 91. How would we do that? Hold on. Right, cool. Seeing it's the battle. The whole thing minus 91 gets us this, yeah? That's the side of our little triangle. Whenever they overlap like this, I like to draw them separate. How would you do 143 minus 91 in your head? $143 minus 90 is how you do it? 140 minus 90, okay. So that's going to be, hold on, 140 minus 90, that's going to be 50, right? But you still need to subtract one more and add 3 more. Does that make sense? Right? We need to add 3 more to get the real answer and subtract 1 more to get the real answer. So adding 3 and subtracting 1, same thing as just adding 2. So if we add 2, we get 52. I'll say that again. Again, you can do this however you want, but the way I would do it is I'd do 140 minus 90. And then I'd add 3 onto my answer and subtract 1 more from my answer. 52. You could have also just subtracted 1 first and got 142, and then subtracted 90 and got 52. It's up to you. So that's 52. This side, what's this side going to be? Whatever what? 88 minus 56 is. Well, that one's not too bad. I'd subtract 50 and then subtract 6, right? That's 32. Are you guys with me on that? 88 minus 56? 88 minus 50 is 38, right? Minus 6 more, 32. Take away 6, take away 50, 32. So let's match up small and large. Smallest on this guy is 32. It's going to go with the smallest on this side, 88. And if all of them are proportional, this statement is true, then we've got side, side, side. How would you solve a problem like Maria? Well, if you're not sure, Alex, yeah?
Divide 32 by 2.
Okay. So Alex is doing what I would do. I'd go for the smallest one and try and simplify that. So we're going to simplify that down, divide by 2. We get 16 over 44. Can we keep going? Yep, divide by 2 again. We get 8 over 22. Divide by 2 again. 4 over 11. Now we're done, right? So the question is, are all these 4 over 11? Oh no, let me zoom out. Are all of these 4 over 11? Well, if it's 44 and we want to get to 4, what will you divide by? 11, right? So that would make it 4. Is 121 divided by 11 also 11?
Yeah.
It is. So that checks out. 52 if we wanted to make it a 4. Think about it. How many times is 4 going to 40? 10. 12 left over. How many times is 4 going to 12? 3. So 13 is what we'd have to divide by. Now the question is 143 divided by 13, is that 11? Right? Because if it is, then we win. Well, I bet you know 13 times 10, 130, right? Add 13 more, 143 must be 11. Check this out. So they are similar by side, side, side. Let's match up our letters. F-E-D, F-R-S. Now you might notice something. Do you see how when they're overlapping, how E went with R and D went with S? This will always be true for overlapping triangles because F goes with itself. There's a joke to be made there. R goes with E, S goes with D.
May I put my stuff away?
Yes, sir, you may. Enjoy your lunch. We're going to practice simplifying ratios tomorrow as our warm-up, because I think that's going to be the key for you guys, being able to simplify those quickly without a calculator. Right here. Not even close. Not even close.
I don't like the way it feels. Should I maybe try it? Go again on Monday? It's just gonna- I'm not going to. I'm gonna put my writers.
How do you guys feel about simplifying the simplest one, or the smallest one? And then checking to get the others, right? Thinking about how would I make that a 4? Well, I'd have to divide by 11. When I divide by 11, does it give me 11 in the bottom two? You guys feel okay with that? We're going to do more tomorrow. But I think that's easy to kind of think of like, how I simplify it.
All my names turn purple, by the way.
What?
We're like blue and green, and now they're all purple.
Oh, so it's like a mountain, and that's like the top of the mountain, and this goes through? Yeah, that does make sense, yeah. And the reason you know this is a good road is because these lines are both parallel, right? Those are
I'm pretty sure I don't have it. I'm not sure what this is. I was gonna go this whole time on, so I think I was so cold.
Some of these on the back page, it's very difficult to tell what goes with what, because of the way the triangles are rotated, they won't know which side goes with which, same with these, the others.
Sure.
So we
Right.
may need to do things like S and C and corresponding, that kind of thing.
Right, yeah.
Because this one will allow x plus 11, well, if you look at the answer, it's 9, so you know that it's gotta go with 30. This one, that's.
Sure. Yeah, that's not enough information to really get
They
done.
don't give the similarity statements.
Right.
So if we had the similarity statements, you could do it. Maybe give them similarity
Yeah, I think that's what
statements.
we're gonna do. Yep.
If we gave the similarity statements on these, then that would force them to use the similarity
Yeah,
statements.
this is a garbage print I grabbed off the internet. I figured I just need some similar triangles, right?
And they don't do the fine points.
Right.
So on 14 and then these last four, we gave her
Right.
the statements.
And if I had enough
similarity
money,
statements.
right, yeah. If I had enough money, if I could do it myself, I wouldn't have to go online and find a free copy. You know what I mean? I could just pop it out. I got a friend who has that. And it's great. Ideally.
But sometimes you have to watch what you.
Right, and ideally, like, I don't wanna use it at all. Like, maybe for the first couple of years while I'm teaching, because I gotta get through this stuff and have stuff ready to go at the last minute, you know, just trying to stay alive. But eventually I want my own worksheets, everything, you know, hand-picked.
Yeah, a lot of my stuff you can tell what I've done because print's really big.
Yeah, sure, right.
And I hate finding it very big because I like kids to have room.
Exactly, that's how I feel too. The last school I was at, they made us print out worksheets from this book they bought, right? You go online, print them out. And there's 20 problems on one page,
We know
squeezed
we
together.
have all of the algebra and geometry books are online.
Online, yes, right. But they had worksheets that we weren't allowed to make our own anything. It was the worksheets, quiz, and everything had to be printed off the book. And some of the stuff was just wrong, right? Especially in geometry. Yeah, exactly. And I spoke up about it.
I never use most of the geometry worksheets, I use the ones.
Right, and I got in trouble in last school saying, this stuff is wrong also, they know for the kids, it's not just pre-typed up,
Like,
you
this
know?
one that I was going to use. You tell me they haven't looked at what.
Oh, I can show you that, this looks like a ton of space compared to what you're doing. I gotta show you some of those worksheets, they were a nightmare, I'm talking, the page was cut in half, so we had double problems, word problems, squeezing